Hello friends, so today we are going to do another important property. So we are just left with two of our important properties for the definite integration. So one of it is this. So this property is also used to change the limit, like the property we did in the previous video, that is 15th video. In that also we changed the limits, and in this property we have also changed the limits. So in the initial we had 0 to 2a as our limits, but in the final we had 0 to a for 2. So this property is actually very useful for applying some of our basic formulas that we did in the previous questions, where we had some of our definite forms that we, like sine to the power nx dx was only defined for sine to the power for 0 to pi by 2, and many of our forms where we had a cos and also multiplied, so that was also defined for 0 to pi by 2. So for solving the for application of our these forms, it is very important to know this property, so that we can actually just convert the question into some of our forms that is known to us to solve the question with much ease. So let me show you some of our questions based on this property. So the first question is, so it is actually, let me first explain the property to you. So we actually get a 2 over here, and we get a property converted from 2a to a. So it is actually used when we have function of 2a minus x is equals to fx. So we can just write directly like this. So let me just show you some of the questions based on it. So the question number 1 is 0 to pi. The first question is the thing that we talked about just a few seconds before, just a few seconds early. So the question is this. So we actually needed the pi by 2 in it. You can apply any of the properties. You're not gonna advantage up by applying like the king's property. If you apply that, you get sine to the power 4 pi minus x. That is of no significant use. So we actually just need the formula that is discussed in this property. So when we apply this, we get 0 to pi by 2 sine of 4x dx. Now we are very now we are very familiar with the form that we have now, because we have 0 to pi by 2 as our limits. So n becomes 4, and we just have 4 minus 1, that is 3 by 4 into 2 by into 1 by 2 into pi by 2. 2 gets cancelled, and we get a 3 pi by 8 as our answer. So this is the advantage of using this property, because we just solved the form that we didn't knew and converted it into a form that we knew. So let me just do the last question based on this property, and we are going to see a significant use of this property in our proceeding videos when we do some of our most important questions. So this is the question which I discussed with you just a few seconds back. This is also the, so we can also use the property over here, but the striking factor is that we are going to use the property 2 times over here, because we have a 2 pi in the question. So when we use it one time, we get 0 to pi as our limit, because we get the limits divided by 2, and the 2 appears in the out of the integration sign. So when we do this, we don't see a significant improvement in the question, so we use it another time so that we get limit of our that we desire. So sine to the power 4x into cos to the power 4x dx. Now this is a very familiar form, and we are going to use the gamma function in it, but a 4 needs to be multiplied. So we have n as 4, and that is also m is also equal to 4. So we are just going to use 4 plus 1, that is 5 by 2 into 5 by 2 upon 2 into m plus n. 4 plus 4, that is 8, plus 2, 10 by 2, which is equal to 5. Now applying this, we have 4 into 3 by 2 into 1 by 2 into under root pi into 3 by 2 into 1 by 2 into under root pi. I hope you know how to use the gamma function. If you don't know that, you can actually watch the previous videos. In that I discussed the gamma function in detail, how to solve it and how to apply it. Let me just solve this question so we can actually just cancel out 4. And now solving this, we get 1 by 12 into the thing in the numerator, that is 9 pi upon 4 and 4 16. Solving this, we get 3 pi by 64. So this is our final answer. So let's keep it till here, and we discussed a very important property on the definite integration. In the next videos we are going to see some of our properties, and the next videos especially for the hidden property that we saw in the 15th video. So stay tuned for the hidden property. Thanks for watching.